All right, next in the unit, we're going to talk about ellipses. So here's what they look like. Basically, you've taken a circle and you've squished it. So there's a few things that we need to know about them. First, we're just going to label some important pieces here. So here is the center of the ellipse. Off of the center, we have a focus over here and a focus over here. And when you say focus plural, meaning there's two of them, you would say foci. That's how you pronounce it. So the definition of an ellipse is that if you take any point on the ellipse and you add the distances from each focus together, it's going to be exactly the same sum as if you took another point and added those distances together, which is exactly the same sum as if I added these together. So an ellipse is defined by all of the points, where if I was to take the sum of each distance, it would be the same. So if you ever want to draw them by hand, that's how you do it. All right. Now, there's a few things that we can go ahead and label in our pictures, just some vocabulary. So first, whatever line goes through the focus and the center and the other focus, that line is called the major axis. And where the major axis intersects the ellipse is called a vertex. So there's two of them, or vertices plural. And then going the other direction, the line that cuts through the center is called the minor axis. And where it intersects the ellipse is called the co-vertex. So when we work with these math problems, we'll be finding all of these different things. And the major axis and the minor axis are always perpendicular to each other. And if you're ever asked what the length of a vertex is, or not the length of a vertex, sorry, the length of an ellipse, it is the distance from one vertex to the other. That's how you know the length. And I'm saying vertex, not co-vertex, so it would be the longer distance of the two. All right, so before we start looking at the equation of an ellipse, we're just going to look at the equation of a circle again because they are actually very similar. Now, it would be possible for me to go through and divide by r squared. So if I had this, and then over here on the right, r squared over r squared is just 1, so I'm going to go ahead and make that just 1. So that is still the equation of a circle. And so kind of the way that you can view this is we're looking, we have our center HK, and from that we have a radius of r, and so if we were to draw our circle, we'd go to the left and right, a length of r from the center. Up and down, we'd go a length of r from the center. It would just happen that those r's are equal. They're the same because it's a circle. You go the same all the way around. The difference between that and an ellipse is that an ellipse says x minus h squared plus y minus k squared, so that part is the same. But instead of having it over r squared and over r squared, we have a squared and b squared, and those values are different. That's why it doesn't look like a perfect circle. It's wider than it is tall, or it's taller than it is wide. All right, so we're going to go ahead and draw an ellipse, and we'll go ahead and start off by doing the wide one. That wasn't too bad. Okay, so I'm going to label my center. Here's my center at HK. And so the A and the B tell you basically like what the radius is for that part. So over here, the A is kind of like the radius to the left and right. So I would say over here, this is a length of A, and this is a length of A. And then the B is kind of like your radius for the height there. So how far up you go from the center and how far down you go from the center. All right, so I'm going to erase some of those because it's making the picture kind of messy. All right, and I'll go ahead and erase this one. Okay, so if we're looking at this picture, hopefully you're seeing it would be obvious that the A value has to be bigger than the B value. And so when you have a picture that looks like this, then your A is bigger than your B. And so if you had B that was bigger than A, your picture would look different, and we'll do that case in just a minute. So here I would say that this horizontal line is the major axis. And so my major axis is going to be defined as the horizontal line y equals k. The vertices that are on the major axis have moved to the left and right of the center hk, and they've moved to the left and the right a distance of a. So I'm going to say h minus a, okay, and h plus a, okay. All right, I also have this line that cuts through the center right here and crosses at these co-vertices, yeah. So the minor axis is what it's called. It is a vertical line, so the equation is going to be x equals h because it goes through the center at h. And then to write the co-vertices, I'm just going to take the center hk, and it moved up and down a length of b. So it's going to be h k minus b, h k plus b. All right, and then of course, we also need to figure out what each focus is. So the focus, it's not halfway in between, it's a little bit closer to the center. And the focus is a length of c away. And you will notice that c is not anywhere in the equation. So c is actually something that we're going to have to solve by hand every time. So in this particular circumstance, when the a value is bigger than the b value, we're going to say c squared equals a squared minus b squared. And that is how we're going to calculate c every single time. So my focus is to the left and the right of the center. Oops. So I'm going to say my focus is h minus c, okay, and h plus c, okay. So there are all the things that we needed to find about that picture. All right, now we're going to do the next picture. So I'm going to go ahead and write the equation out again. Only this time, we're going to be this shape. That could have been worse, but it could have been better. Okay, so again, here we have our center at HK. All right, this time, this line right here, instead of defining the major axis, this time it is the minor axis. So in this case, we know that the, well, I guess I'll go ahead and label it. Here's my A value, and here is my B value. And so I know this time that the A must be smaller than the B. And so my minor axis is going to be a horizontal line, y equals k. And this time, since it's the minor axis, I'm finding the co-vertices. And the co-vertices from the minor axis went a distance left A and right A. So h minus A, k, h plus A, k. All right, the major axis would be this one this time. So that is a vertical line at x equals h. And this time my vertices are going up a value of b and down a value of b. So h k minus b, h k plus b. And the focus is always on the major axis. And so here's a little focus there, here's a little focus there, and so this is going to be a length of c. And this time, since the b value is bigger, when we find this by hand, we're going to write c squared equals b squared minus a squared this time. So you're always just subtracting the smaller number from the bigger number. All right, so on this one, my focus moves up and down instead of left and right. It's up and down from the center, and I'm going to say h, and then we'll say k minus c, and h, k plus c. So that's how we would find the foci. All right, so here is an example. Let's say they have asked us to graph and identify the foci, vertices, co-vertices, major and minor axes, of x plus 2 squared over 1 plus y plus 1 squared over 16 equals 1. All right, so when you draw the graph, I'm okay with you guys just doing a little sketch. Ultimately, you'll probably want to sketch a lot of these anyway because the intuition is really helpful for memorizing all these different things we have to find. So the center of our graph is going to be -2, -1. So -2, -1 is like right there-ish. All right. Now this one, to the left and right, if we think of the radius to the left and right, we know that our a squared value is 1, and so a is also 1. So to the left and the right, I'm going to put 1, little dot, 1, 1. All right, and that would also help me find my co-vertices. It's not very far. I'm not going very far, so that's the co-vertex there. And then my b squared value is 16. So my b value is 4. So I'd go up 4, and I'd go down 4. All right, and then that would be my ellipse. So I'm going to go ahead and write down some of this information that we've already found so far. So our co-vertices, I went to the left one and I went to the right one. So from the center, if I go left 1, I get -3, -1. If I go to the right one, I get -1, -1. My drawing's not very good. All right, and then for my vertices, I went up and down 4. So if I go down 4, then I have -2, -5. If I go up 4, I have -2, +3. So there's my co-vertices, my vertices. I'm going to go ahead and draw the ellipse so you guys can see it. Okay. Next, I want to look at my major axis and my minor axis. And so my major axis is the longer axis. In this case, that's a vertical line. And it's the vertical line going through the center. So it's going to be x equals -2. My minor axis is my horizontal axis. In this case, horizontal line, so y equals, it's going through the center at -1. All right, now I think we just need to find the focus. Is that on there? Yep, foci. So to find the focus, we just have to do c squared equals b squared minus a squared because we want to do the bigger number, take away the smaller number. So I'm going to say for my focus, c squared equals b squared minus a squared. And so c squared equals 16, take away 1, which means that c squared is 15. And so my c value here is a square root of 15. Now notice I didn't do plus or minus the square root of 15. The reason is it's a distance, and distance is always positive. So I'm just going to use c equals the square root of 15. Now this particular square root doesn't simplify. If it could simplify, you would have to. It's like the whole factor tree thing. So square root 15 is a pretty good one. Okay, in this case, my focus is always on my major axis, so it'd be somewhere in here and somewhere in there. And so when we write the focus, we're going to move up and down from the center. And the amount that we're going to move up and down from the center is the square root of 15. So my center was -2, -1. So I'm going to say -2 and then -1 minus the square root of 15. And then -1 plus the square root of 15. And I didn't even have to get out my calculator to do that. Please leave the square root in the problem. Please do not round that number. Just leave it just like that. That'd be perfect. So notice I didn't have to do a perfect graph to get all that information, but a little sketch goes a long way.